Hello everyone, welcome back to my channel Code with Khan. So if you are new to my channel, please subscribe to my channel. Let's see today's LeetCode problem. 1622 fancy sequence. It is marked hard. Now let's read the question. Write an API that generates fancy sequences using the append, addAll, multAll operations. So we need to implement the fancy class. So fancy class contains fancy constructor which initializes the object with an empty sequence, and then append value method which appends the integer value to the end of the sequence, and then addAll method which increments all the existing values in the sequence by an integer increment, and then multiple all method which multiplies all the existing values in the sequence by an integer m, and then getIndex method gets the current value at the index from the sequence. Then we'll apply the modulo. If the index is greater or equal to the length of the sequence, then we'll return -1. That means, so if they are requested for the index that is not present in the sequence, then we'll return -1. So let's see the operation. So fancy, first we'll have the fancy constructors which initialize the an empty sequence. So we'll take a new array list. So we'll initialize it with the empty array list. Okay, on the append method. So what is the append method does? So append method, so when we initialize the list, it would be empty. So what append method does is, so append of value which appends the value to the list. So we'll append value to the list. And what addAll method does is, so we need to add the increment value to the all the values in the sequence. So value, this is add, right? So it would be inc. So we need to do it for the all the values in the sequence. And what is the multiply-all? So multiply-all method uses to multiply all the existing values in the sequence by an integer m. So what it does is, if you have value in the sequence, we need to update multiply all the values with the m, all the in the for the all the values in the sequence. Got it? So these are the operations present in the fancy class. Now let's read the constraints. Constraints are, this value increment at m can be less than or equals to 100, and index can be 10 to the power of 5. Okay, and at most 10 to the power of 5 calls total will be made to append, addAll, multiply all, and getIndex operation. So we are going to see 10 to the power of operations to all these methods. Okay, now let's see the one input. So initially they are calling the fancy constructors. So what happens when we call the fancy constructors? So it initializes the new array list. So it would be an empty array list. Okay, and then let's see next operation append. So append of what? Append of 2. So what we'll do, we'll append 2 to the sequence. So let's call it as a sequence. Sequence is equals to 2. Now what is the second operation? Second operation is addAll of 3. So we got a operation called addAll of 3. So what we need to do, we need to add this 3 to the all the values in the sequence. So we have only one, so it will become 2 plus 3. So now the sequence becomes 5. Okay, what is the next operation? Next operation is append. Append of what? 7. So we'll append 7 at the end of the sequence. Now the sequence becomes 5 comma 7, 5 comma 7. Now the next operation is multiply all by 2. So multiply all with 2. Okay, so we have two values in the sequence list. So what we need to do, we need to multiply with 2. Here also 2. So now this becomes 5 into 2 is 10. This becomes 7 into 2 is 14. Now the sequence becomes 10 and 14. Okay, now the next operation is getIndex. GetIndex is of getIndex of 0. So 0 is present in the sequence. So what we'll do, we'll just return 10. Okay, now next operation is addAll. addAll of what? addAll of 3. So we need to add plus 3 to the all the values in the sequence. So 10 plus 3 and 14 plus 3. So 10 plus 3 becomes 13 and 14 plus 3 becomes 17. So this is the final, this is the sequence becomes after addAll. And then append method. So append of what? Append of 10. So what we'll do, we'll append 10 at the end of the sequence. And then next operation is multiply all. So multiply all with what? 2. So we'll multiply all with the 2. 13 into 2, 17 into 2, and 10 into 2. So now the final sequence becomes what? 13 into 2 is 26, 17 into 2 is 34, and 10 into 2 is 20. So these are the final operations we have seen. The next operations are getIndex, readIndex. So now this is the final sequence we are seeing. So now we got getIndex of 0. GetIndex of 0, what we have, value at the 0th index we have 26. We'll return 26, and getIndex of 1 will return 34. GetIndex of 2 will return 20. So this is the final values, and this is the final sequence we are seeing. Okay, so this is a brute force approach. So we are doing simulation. So we are performing all the operations one by one, and we are manipulating the sequence list. Okay, now what they are saying is, so they are going to call these operations 10 to the power of 5 times, right? They are going to call these operations 10 to the power of 5 times, and we each time, so for example, if you have called addAll or multAll, so if you have called, they have called these methods. So what we are doing, we are manipulating all the values in the sequence, right, one by one, right? For addAll, we are adding to the each and every value in the sequence list. So it becomes 10 to the power of 5 into, so whatever we have, so it can also be, list can also be have 10 to the power of 5 elements. So if we call addAll for 10 to the power of 5 times on a list of 10 to the power of 5, so it becomes 10 to the power of 10, so which is greater than or equals to, which is always greater than 10 to the power of 8. So we will see TLE exception. So we can obviously get the time limit exceeded exception. Okay, now what is the better solution? So what is the optimal solution? Okay, let's check for the optimal solution. Let's take the same example. We will have initially 2 comma 3. So let's say we have 2 comma 3 in the sequence. Okay, what they have requested is, they have requested for add all of 5, and then, so they have requested for addAll of 5 and then multiply of with 2. Okay, now let's see. So with the simulation, what it becomes, we are need to add 5. So 2 plus 5 becomes 7, and 3 plus 5 becomes 8. So sequence becomes 7 comma 8. Now we need to multiply. So with the multiplication, it becomes 7 into 2 14, and 18 into 2 is 16. So the final sequence becomes 14 into 6. So what I will do is, I will not perform the operations on the sequence. I will not perform the operations on the sequence list. So what I will do is, I will store the operations, right? Instead of performing the operations each time, I will store the operations. What are all the operations we need to perform on the sequence list, right? So what I will do is, I will take two variables. So mainly we have two operations. One is add and then multiplication. So I will take two variables. One is for add, initially it would be 0, and then another one is mult. So it should be initially 1, because the multiplications cannot be, we cannot do it the 0. So it will be add and multiplication. Okay, so what I will do is, so whenever they are requested for the addAll, so I will not update the sequence list, I will update here. So I will store the add operations. What I will do, I will do 0 plus 5, so add becomes 5. Okay, now let's see. Now I have 2 comma 3 sequence initially. Okay, what I will do is, I will so whenever they requested for addAll of 5, so I will updating the add variable. Okay, now next is multiply of 2. So what I will do is, instead of performing the operations on sequence, I will do multiply 1 into 2. So now multiply becomes 2. Okay, now they have requested for a index, get index of 0. So what I will do, I will get the value from the sequence, which is 2. Now we have operations needs to be performed, right? So what are the operations? We need to perform add of 5 and then multiplication of 2. Now it becomes 2 plus 5 is 7, and then into 2, which is 14. So this is the value that we have generated at the simulation also, right? So by doing the simulation also, 0th index we got 14, and by storing the operations and performing the operations whenever they have requested for particular index, so we are not doing it for the all the values, though whenever they are requested for particular index, then we are applying those operations. So we got 14. Okay, now let's see. one more example. So same, we have 2 comma 3, and they have requested for add. So I have so let's take add is equal 5 and multiply is equals to 2 only. Okay, so now if you see, when they are requested for index 0, so what we are doing, it is 2 plus 5 cross 2. So if we expand this, so what it becomes, 2 cross 2 plus 5 cross 2. So what it is, our initial value is 2, our original value is 2, right? So we have only 2 in the sequence, but and we got multiply with the 2, so we are multiplying it with the value which is in the sequence, and we are multiplying it with the value that we got in the add request, right? We are multiplying it with the add request and we are multiplying it with the original sequence. So whenever they are requested for the multiplications, we need to update the multiply also as well as add variable also. So what it means is, so we got a request saying multAll with 2. So what we are doing, we are doing multiply the value in the sequence as well as the value which is in the add variable. So what we'll do, we will simply update the multiply is equals to multiply into this value which is 2, and then add is equals to add into 2. So at the end, so while we are getting the we are calculating the operations on the index, so it become easy for us. So what we'll do is, so let's take one example, same example, we'll have 2 comma 3, and we got add 5 and multiply of 2, right? Now let's see, let's take from initially. So requested for add all of 5 and then multiply all with 2. What I will do is, we'll take two variables, add equals to 0 and multiply is equals to 1. So they have requested for add. So what I will do, I will simply update add 0 plus 5 becomes 5. So they have requested for multiplication. So multiplication becomes 1 into 2, which becomes 2, and I will update add also. So what I will do, 5 into 2, so it becomes 10. Now what the so now here what we are doing, we are multiplying it with the sequence which is original sequence in value in the sequence, plus we are doing plus with the this is nothing but the add, right? So this is original value and this is the value that we are multiplying, so it becomes multiplying. So what is the formula becoming? Formula is value cross multiplication plus addition, because we are multiplying the addition add variable already when we are calculating the multiplication. So now the formula becomes value cross multiplication plus addition. So if we check the value in the sequence, now they have requested for get index of 0. So what we have in the 0th index, we have 2, right? We are not updating the sequence, so we have 2. So if you apply 2 here, 2 into what we have in the multiplication, we have multiplication as 2, plus what we have in the add, we have 10 in the add. So now the formula becomes now the value becomes 22 is 4 plus 10 is 14. So this is the value we got in the simulation also, 14. Okay, now we got the formula for getting the value at the particular index. So what is the value? So whenever they requested for the value, so what we'll do, we'll get the value from the sequence. So sequence dot get the index, and then we'll just return the value by applying value cross multiplication plus addition. Okay, got it? So this is the formula for calculating the value instead of updating each time, updating the sequence each time. So we'll store the operations in the add and multiplication. Okay, got it? Now let's see one more case. So where, so okay, what is this is called? So what we are doing here, we are not updating the sequence each time. So we are updating the value whenever they have requested for the particular index. What it is called is, it is called lazy transformation problem. Transformation. So this is called as lazy transformation problem. Okay, Now let's see one more scenario. So where we have initially 2 comma 3 in the sequence. So they are requested for add all of 5 and then mult all of 2, and then they are requested again for add all of 4. Okay, let's see what it become in the simulation. So in the simulation it becomes 2 with add all of 5, it becomes 2 plus 5 is 7, and then 3 plus 5 is 8. Okay, next is multiply of 2. Multiply of 2, 7 into 2 becomes 14, 18 into 2 becomes 16. Now third operation is add all of 4. So 14 plus 4 becomes 18, 16 plus 4 becomes 20. So this is the final sequence we got from the simulation. Now let's check with our optimal approach. So what is our optimal approach? Optimal approach is, so we will take two variables, add is equals to 0 and multiply is equals to 1, and we have sequence 2 comma 3. So what they are saying, add all of 5. So what I will do, I will update it with the variable here, so it becomes 5. Next is 2, multiply of 2. So if we do multiply of 2, so multiply of 2 means it becomes 2. Okay, now next is add all of 4. So add all of 4 becomes, so we'll update. So what I said, whenever they are requested for the multiplication, we need to update both multiply and add. So it becomes 5 into 2, which here it becomes 10. Okay, now what is the third thing? Third thing is add all of 4. So add all of 4 becomes 10 plus 4 becomes 14. Okay, these are our final variables. Now let's see. So they have requested for a variable at the index 0. So if you apply the formula, it becomes value cross multiplication plus add. So value is 2, multiplication is 2, and add is 4. 20 to 4 plus 14, which is 18. So this is the value we got at the index 0 in the simulation also. Okay, this is fine. Now we got another operation, which is append. We got append operation here. So append of what? So let's append 9. Let's append 9 here. So now sequence becomes what? In the sequence, in the simulation, it becomes 18, 20, and then 9. So this is our sequence. Now here what our sequence becomes? It becomes 2 comma 3 comma 9. Okay, now if the requested for index 2, get index of 2. So if they have requested for get index of 2, so what we have to do? So we know that we need to apply formula. So what I will do is, we will simply check is index 2 is in the range. So it is in the range 0, 1, 2. So it is in the range. So what we need, so we'll apply the formula and we'll return, right? Obviously, right? What we'll do, value cross multiplication is value is what? Value is 9 cross multiplication of what? Multiplication of 2 cross plus addition of 14. So it becomes 18 plus 14. So it becomes 12, 3 becomes 32. So we'll return 32, which is incorrect, right? So we have just appended it to the sequence, and it has only 9 at the index 2. But since we have stored the operations, right? We have stored the operations. We are applying these operations when they have requested for that, right? Even those operations are not applicable for the newly appended value. So those operations are not applicable for the newly appended value. They came prior to this append operation, right? So those are only applicable the values which is present previously before these operations. So this value 9 is added after performing these operations. So which is not applicable, right? Adding this doing this multiplication and adding this add to the value. So what we can do is, so when they requested for append, so we know that while returning, we are doing multiplication with the value plus addition with the value. So this is a confirmed formula, right? We cannot change this. So what we will do is, when we are appending, I will subtract this add from the value, and I will so we are adding at the while returning, right? So what I will do is, when appending, I will subtract this add, right? I will value is equals to value minus, I will do value minus add. And what I will do, since we are multiplying with the mul, so I will do division here, value divided by mul. So now it becomes stable, right? Here we are removing, I mean we are here we are removing the add, and then here we are dividing the mul. So and we are, while we are returning, so we are multiplying the with the mul and we are adding the add variable, so it will be constant, so it would become stable. So right, so what is the operations we need to do? So let's write our operations. So whenever they have requested for the append, so whenever they have requested for the append operations, what I said, we need to let's combine these two operations. So it becomes value is equals to value minus add, and then we need to divide it by multiplication. So and then at the end we'll append it to the sequence. So sequence dot add of value. So this is what we have to simply do. Okay, what is the next operation? Next operation is addAll operations. So what is the addAll method? So let's take value also. So what is the addAll method does? So we need to simply update the add variable. So addAll becomes add is equals to add plus value. Okay, there's the next operation which is multiply. So multAll of value. So what I said, in the multAll conditions, in the multAll operations, we need to update both add variable and mult variable. So what I will do, mul becomes multiplication into value, as well as we'll update add also. So add into value. So we're updating these two variables. Okay, so what we need to do, at the get index method, get index will take index as an input. So what we'll do, case of get index method. So in get index method, what we need to do is we need to check if index is in the range or not. If index is greater than or is equals to sequence dot size, then we'll return -1. Otherwise, we'll get the value from the sequence. So we'll get the value equals to sequence dot get from the index, and we'll apply the formula. Right, we'll apply the formula. Formula will become formula. What is the formula? Value cross mul plus add. That's it, right? So these are the operations we need to perform. So this looks simple here. So these are fine when we have the values, less values, but our values can be up to 10 to the power of 5, right? So if we do multiplications, additions, and like multiplication multiple times, so we can perform multiplication 10 to the power of 5 times. So the value becomes large, right? So that's why they have mentioned in the problem, right? They have mentioned in the problem that, so we need to store the values, right? If you go to the problem, they have mentioned that we need to store the values in the form of 10 to the power of 9 plus 7. Okay, now we need to store the values in the 10 to the power of 9. Otherwise we'll obviously get the like wrong results, right? So for that reason we need to store the values in the modulo of. So now let's see, mod is equals to 10 to the power of 9 plus 7. Okay, so at each operation, right, we are doing the minus here and we are doing division here. So each time we need to apply the modulo for the better results. Otherwise we'll get the wrong results. So let's see how we can apply modulo for these operations. For the first operation, let's see how we can apply modulo for the first operation. So we can do value minus add mod, right? We can do this one. Okay, for if this becomes negative, right, our value is we got value of 1 minus add is initially 10, now this becomes -10, right, which becomes negative, right? So which is not correct. So what we will do is we will append mod to the value, so it becomes positive. Got it? So this is one operation, and the second one is division of multiplication. Okay, so division of multiplications, so let's take it as 1. So let's take it as equation x. Let's take it as equation 1. So equation eq1. Next operation is division by divide by mul. So divide by mul, we can write it as, multiplication 1 by mul, right? So for this one we need to apply the mod. For this one also we need to apply the mod. So how we can apply the mod on this one? So we cannot apply 1 modulo m by mul modulo m. So which is not mathematically correct. So this is not correct mathematically. So how we need to do? Apply modulo on this function. So 1 by mul becomes multiple of inverse, multiple ki inverse. So it becomes multiple inverse. So there is a formula. So there is a theorem called Fermat's little theorem. So Fermat's little theorem to find the any values inverse. So here, what is the Fermat's theorem is? I will explain it simply. So what is the Fermat's theorem is? For any given x, if you want to find x inverse, it becomes x to the power of mod minus 2 modulo m. So if we apply that here, so we have multiple inverse. We need to find multiple inverse. So if we apply that formula here, it becomes multiple to the power of mod minus 2 modulo of mod. So let's combine. This is the equation 2. Now let's combine this equation 1 and equation 2 for our append method. So what it becomes? It becomes value minus add mod of mod, and then we need to append mod, right? Cross equation 2 is what? Multiple. So equation 2 is, let's write it in the coding form. So we need to find power of multiplication comma mod minus 2, and then we'll apply mod on this one. So mod of modulo. Okay, so this is the value we need to find before appending. So now let's initialize it to the value. Now we'll append this value to the sequence dot add value. Alright, so by doing this we will be getting the value. Okay, so let's apply modulo on this function. So add function. So add function, this is simple. So we'll add the value and we'll do the modulo. Okay, this is add function. Let's do this for the multiplication. So this is also simple. So we'll do modulo for this one. So this is also simple. For add, we'll do modulo of add into value. Okay, now let's see in this place. So in the getIndex place, so we are doing returning the -1 if index is not in the range. Otherwise we'll getting the index, and we are calculating value into multiplication into add. Okay, let's see how we can apply modulo here. So we are already performing operations before, right, for the appends, multiplication in the all the places. So what we can do is here, so I will simply do value into multiplication plus add modulo of our mod. So since we will be going to use long everywhere, so before returning this long, I will convert this into the int, and then I will return. Alright, this is the simple formula in the getIndex method. So now if we go back and check, so what are the methods? First one is the fancy constructor. So it will initialize an empty sequence, and then next one is append method. So what is append method? Append method is appends the values at the end of the sequence, but before appending the value, so what we have to do, we have to perform these operations. We'll removing the minus from the sequence, and then we'll be doing we'll dividing it with the mul also. To performing that one using the modulo, so we are going to use this formula for getting the value, and then we'll add that value to the sequence. And for addAll method, so we'll only update the add variable. So we'll do the modulo with this one. So it would be add plus value modulo m. Okay, and then for multiplication, we'll be updating both multiple and add variables, and we'll doing the modulo for each operation. And the getIndex thing, we'll checking if index is in the range or not, and then if it is not range, we'll return -1. If it is in the range, we'll apply the formula which is value into multiplication into add, and we'll apply the mod at the end, and we'll convert it in the int because we are storing all the long values, and then we'll return the answer. Got it? So I think that's it. Now let's see the time complexity. Okay, what is the time complexity for this code? Are you doing any extra operations? So if you see, for append we are only calculating the values, and for this power thing, right, for finding the power, right, so we need to write our own method, right? So for finding the power of multiply comma mod, we need to write our own method, because we need to, at each operation we need to apply the modulo, right? Otherwise it becomes very large, like so it returns a double value, so which is not correct. So that's why we'll write our own method for finding the power. So for finding the power, we know already it takes log of m, right? Log of for any value, right? For any value m, so it takes log of m. Okay, and then so we are doing operation for 10 to the power of 5 times. So any operations, right? Add, append, addAll, or getAll. So it will take 10 to the power of 5 operations, and each operation, so if it is the append operation, that it will take log of m. Okay, what about the addAll method? So addAll only appends value to the add variable, which is big of 1, and multiply all is also same, which will take only big of 1. And then this getIndex method, what it does, getIndex method only gets the index from the sequence, and then we'll do some calculations, and here we'll directly return, so it will also be big of 1 only. And what is the space complexity? In the space complexity, we are not using any space except that list which is requested to generate it, so that would be space complexity would be, we are not using any extra space except that sequence, so for the reason it will be big of 1 only. So time complexity become log of m, and space complexity will become big of 1. Okay, now let's try to write code for this. Okay, let's take a list of long, let's call it as a sequence. We'll store the sequence in this list, and then we'll take two variables called add and then long mul. Okay, these two to store the operations, add operations and multiple operations. So in the fancy constructors, we will initialize these variables. So sequence is going to be new array list, and then so add is equals to 0, and then multiple is equals to 1. Okay, now first let's write these, and we need to take mod also, right? We'll take mod also. It will take int, let's take it as mod, which is equals to 10 to the power of 9 plus 7, so 1 2 3 4 5 6 7 8 9 plus 7. Okay, this is mod. Now let's write the addAll method first. So what we'll do in the addAll, so as I said previously, we will do simply add is equals to add plus this increment, so add plus increment, and at the end we'll do the mod. Okay, now let's write method for multiplication all. So in the multiplication method, so we need to do update the multiply variable as well as the add variable. So let's first update the multiple. So multiple will be, so mult into m, and then mod of modulo of mod. Okay, same update the add is equals to add cross m, and then modulo of our mod. Okay, now let's write getIndex method. So in the getIndex method, what we need to do, we will check first if the index is in the range or not. If idx is greater than or is equals to sequence dot size, then we'll return -1. Otherwise, what we'll do, we'll apply the formula. What is the formula? We'll first fetch int. So we'll first let's try to let's directly apply the formula. So what we'll do, we'll return sequence dot get of the index, and then what is the formula, into multiply and then plus add. So this is our formula. Now we need to apply the mod on this, so we'll apply modulo of mod. Okay, now let's write this in the parenthesis. So once this is done, so we need to this will return as long variable, so we need to convert this into a integer. So what I will do, I will use int typecasting to, I will typecast it into int. Alright, that's it in the getIndex method. Now let's write the append method. So what is the append method? So in the append method we need to update the given value before adding it to the sequence list. So how we need to update? So we'll take long new value is equals to, so initially we need to remove add from the value, right? So we'll take value minus add, then what we'll do, we will do apply modular on this one, so it would be mod, and then once that is done, we'll add mod to this one, because to avoid the negative values. Now let's write this in the parenthesis, and then we need to multiply it with the Fermat's little theorem. What is the Fermat's little theorem? I will write our own method called power of multiply mul into, which is mod minus 2. We need to find the power of multiply comma mod minus 2, and then we'll apply modulo on this. So we'll apply modulo on this one. That's it. So I will be copy pasting this power method. Please check out that power method. So it would be simple finding the power. So while finding the power, at each time we need to apply the mod. That's it. Okay. Let me copy the power method. Okay, I have copied the power method, so which is to find the power of multiply comma mod minus 2. So goes through this power method. So simply to find the power, so while applying the mod every time on each operation, and then so we forgot to add, so generate a new value to the sequence. I will sequence dot add new value. Okay, now let's try to run this code. Yeah, it is accepted. Now let's try to submit this code. Yeah, it is accepted. Yeah, if you like my content, please do like, share and subscribe, and if you have any questions, please comment it out. Thank you.